Good morning or good afternoon, and welcome to this edition of the FDTD Satellite Applications webinar. Today, we're very happy to have Alex Edwards, who's a meteorologist in the Bismarck, North Dakota Forecast Office, talking on the use of NuCap soundings in mesoanalysis on a conditional severe risk day. Next slide, please. This is part of an ongoing series of webinars led by forecasters in the office. Dan Bikos and I are always looking for speakers. If you want to give a talk, or if you know someone who you think should give a talk because they're an expert on something related to satellite imagery, send us an email. Next slide, please. Just to go over a little bit of the protocol, this talk will be about 20 minutes long. There'll be Q&A via chat, or you can ask during this phone session at the end. We should be done by 1/2 or 18:30 UTC. Don't press hold and mute when you're not speaking. Having said that, take it away, Alex, and thank you.
All right, thank you very much. Like you said, I'm from the Bismarck WFO up here in North Dakota. Today, we're going to look at an August 7th, 2020, a late summer or middle of the end of the summer day, a severe risk day in western North Dakota. And we'll jump right into the kind of quick overhead look here, which should look very familiar for most of the CONUS for that kind of late summer, August 500 millibar pattern with a broad ridge over most of the southern CONUS there, and that ridge centered over the southern plains. Looking towards the northern plains, we had a relatively potent shortwave trough crossing the northern Rockies there, approaching our area, but pretty far to the north even for us, kind of tracking along the Canadian, the international border there. And then the other thing to note was there is a little subtle ripple in the 500 millibar heights there, kind of over the central Dakotas, and that's due to some morning convection. So this is the 12Z, the morning 500 millibar chart, and we're going to start there as we progress through the day, as we go from the day shift to the evening shift in this setup and the forecast problems that arise out of that. Oops, excuse me. One more look aloft here at the 12Z 700 millibar analysis, and you can see the morning convection, the impact it has on the analyzed relative humidity field over the central and eastern Dakotas there, and we'll have exiting convection there during the day that we'll see there later. You can see the front associated with the shortwave to the west, and actually a fairly potent thermal ridge in the 700 millibar field there ahead of the front as that shortwave begins to push into the region. So some pretty good 700 millibar temperatures with that ridge extending into southern Saskatchewan there. The more relevant portion to this is certainly the lapse rates, and they are steep at 12Z, especially out along and ahead of that trough to the west. We're looking at an exceedance of 8 Celsius per kilometer, approaching 9 there in eastern Montana and western North Dakota. So certainly a strong elevated mixed layer we can see from that, and that extends well into Canada, as you can see. And so that's certainly going to be a player today as that trough approaches, and what kind of severe more convective risk comes out of that trough. Looking at an upstream observation, this is taken from the morning balloon launch in Glasgow, Montana, which is northeast Montana for those of you who aren't familiar. And so that's, if we go to northeast Montana, that places us in a pretty good upstream observation site for the air mass that's going to track over our CWA, which is western and central North Dakota. And so here we can see, as we look at the 12Z observed sounding at Glasgow. Certainly the lapse rates that we were talking about before, and along with that is a very dry, lower level boundary layer is going to certainly mix out as that tracks to the east. So that's going to be an issue unless we can get some sort of low-level moisture source for figuring out the day's convective risk. Looking at the surface that morning, we can see the air mass, the boundaries laid out fairly well. It's not a terribly complex surface analysis. We have our front or prefrontal trough in the west, crossing central into eastern Montana. Our warm sector kind of over far western North Dakota, and then eastern Montana, and then ahead of what's basically the warm front there on the north side, we have our cloud cover, cooler temperatures, and that kind of flow along the front there. The thing to note here is our dew points. This is 12Z. This is before our diurnal mix out. So we're looking at surface dew points right now in the early morning in the upper 50s. There's some low 60s in there in western North Dakota, which by itself, looking at that potential mix out, you would think those should drop without any other source of moisture there. But we do see further south into South Dakota, we have dew points in the upper 50s, low 60s into mid 60s there. So it's a little better as we expect that southerly fetch with the trough incoming to increase. And then even into Nebraska, actually, we have mid to upper 60s, maybe a few 70 dew points in there. And so that southerly flow ahead of the trough in the warm sector there should really help maintain those dew points. And we hopefully shouldn't mix out too much if you're concerned, if you're trying to bank on more widespread convection. But it's going to take a lot with that elevated mix layer, and that's going to be part of the problem today. This is the morning day cloud phase, which is always a favorite for picking out what layers, what levels of clouds we're looking at, what the environment is doing. You can see our widespread cloud cover out along and ahead of that warm front. We have convection in the eastern Dakotas there, more in eastern South Dakota. You can see the clouds associated with the incoming front in central Montana there. Nothing terribly impressive yet. This is still in the 13 to 14Z range, so still early in the morning. The other interesting point I think here is that we talked about this southerly moisture advection that we would hope to maintain some sort of modest, at least, boundary layer moisture profile. And we can see actually the northward advancement of stratus in Nebraska, South Dakota. I mean, you can, at the end of that little loop, see that inching towards the North Dakota border in the central over the Missouri River there. So certainly there is going to be some help in maintaining some sort of boundary layer moisture. So it's not like a complete, high plains mix out, essentially. So this is, it does paint that picture of, maintenance of some sort of this front approaches, and likely arrives in western North Dakota later this afternoon. Looking again, same time frame. This is mid-morning. The water vapor loop from code 16 is interesting. You can see the warm, dry colors from the elevated mix layer fairly well, extending from the southwest, from the Wyoming region into the Dakotas, well through South Dakota and then into North Dakota as well. You can see the mid-level moistening along the front there, pushing into eastern Montana. So there is at least that we can see with the subsidence to the west of that. So that's going to be our area of focus, is that strip essentially of mid-level moistening there seen on satellite in an otherwise very warm and dry mid-level that's going to otherwise suppress more widespread convection. So along this trough, this convergence field associated with that mid-level shortwave that's going to be our focus for the day. So the SPC Day 1 Outlook at 13Z, this was essentially what it looked like at the 6Z Outlook, and then actually the Day 2 Outlook essentially looked the same as this. It had a slight risk for kind of the west central portion of the state, further and then on further east, and then with a marginal right along there, trying to bank on where that front will land right around the diurnal, the really prime convective time in the afternoon as that front advances eastward. So that's what we're advertising, is this slight risk of severe weather, and that's going to be associated with the hail and wind. Not much of a tornado threat, at least in our CWA at this time. So that's a slight for hail and wind essentially there. Now here's where we start to get a little complicated with our forecast. This is the 12Z initiated convective allowing models, and we have a variety of cores here, a variety of boundary layer biases and schemes, and this is valid at 0Z that evening. And well, you can kind of see where the front should be, and it's in the west central portion of the state. Maybe the HER hints at it, but universally there's nothing there. There's the 12Z initiated cams, whether you look at the HER, the Nestle, the NAM nest, etc. None of them are producing anything. Maybe one of them later on in the evening tried to kick something up, but this is pretty much consistent 20Z through 0Z in our valid time, where they're not producing anything reflectivity wise, and that's certainly going to be how they it can be blamed on how they handle this elevated mixed layer, this capping potential. And so this is what we're looking at early in the morning once we start to open the model data. Well, the 12Z NAM nest, if we want to start getting into forecast soundings, which are certainly important here to further contextualize what the convective allowing models are doing. This is placed at Dickinson, which is about an hour and a half west drive of Bismarck, over there starred in western North Dakota. And this is valid at 20Z, so about the time that front should be in the western portion of the state. And certainly there's ample drying and warming of the mid-levels there. There's a stout mid-level cap, the capping inversion there. The ML sin is substantial, negative 155 joules per kilometer in that area. And so it's tough to see out of that sounding anything forming. Now, above that, there are the lapse rates, you know, that we were talking about before. There's the potential instability there where our lapse rates are nearing 9 degrees Celsius per kilometer. But again, the ML sin at negative 155, enough cape there. If you could adjust the environment a bit, but that convective inhibition really doesn't lend a lot of confidence to more widespread or any sort of convection that day. Looking at the HER here, apologies for the different looking soundings there, but two different mechanisms. This is the HER valid at the same time. Looks quite a bit different. Doesn't have quite as much drying in the mid-levels, the warming in the mid-levels, where the cap that was previously focused at about 700 millibars isn't quite as pronounced. There are its own separate issues. Here, the boundary layer is likely overmixed, which is a common bias with the HER or even the RAP based soundings that we see, and that can have an impact on what the model produced instability is as well as obviously like the mixed layer convective inhibition. So here, if we were matching up what this sounding compared to in Dickinson again, we're looking at maybe about a 6-degree difference in the surface dew point, where the sounding from the HER is, producing a much lower surface dew point of 52. It's mixing out too much compared to what the actual surface observations were at the time. And now if I go back actually real quick to the NAM, we do see it's fairly more representative of the surface conditions. It's just the difference in the low to mid levels where that warming subsidence is creating much more of a capping inversion there. And so we kind of have two different scenarios, and neither of them are producing convection in the cams. So what are we going to do? How are we going to convey this? Let's move forward. Well, 1630Z comes along, and SPC sees the same thing as we do. Likely some collaboration there, but the slight risk is drawn further east, and now we are essentially downgraded to a marginal given the uncertainty and the capping issues that we see there. And so now we're reduced to our 5% hail and wind potential. And so we're in a downgrade during the day. All right, so obviously we're not going to read this, but just to highlight some messaging uncertainty from both SPC and Bismarck, this is where we start to try to get into like how do you downgrade your message, how do you but still account for the potential if something does happen. And so SPC and us are talking here, our mid-level height rises ahead of this trough, maybe some subsidence, this capping issue. Additional issues include westerly flow aloft. There's parcel detrayment if you do get towers. There's going to be all sorts of mitigating factors that scream less convective, severe convective potential that you would otherwise think would be associated with this front. Again, in the Bismarck AFD, the same issue. There they highlight forcing associated with this shortwave that I showed before does stay more north of the international border. There is the trailing front that pushes through, but again, the forcing, the ascent, the mid-level moistening is likely forced further north. So maybe there's a sweet spot there, but we're not sure, and certainly the coverage is going to be a question if there is anything. All right, so I want to take you through our shift change real quick. It's 20Z, 3 p.m. local time here. We got the day shift leaving, the evening shift coming on. We have several issues here. We have weather graphics. We have our discussions, as I showed before. On the graphic side, this involves a purposeful downgrade, essentially, and how you want to convey a threat. We had an SPC Outlook in our early morning graphic, and that's been quote unquote downgraded to just an isolated thunderstorm mention due to this uncertainty, and most of the CWA isn't going to see a thunderstorm. So this is obviously the challenge in trying to convey these threats. But the weather story undergoes a downgrade. Also, there's staffing issues. This is last year. This is August. This is we're still in obviously the COVID era. So we have minimal staff here at the office. There's 2 people on the day shift, 2 people on in the evening. And so we change at 3 o'clock. Not much is happening at that time. AFD is out. But the evening shift has its own responsibilities to be accounted for. We have forecast updates, TAFs, and then the 0Z balloon, actually, the upper air launch has to be performed as well. So if something does happen, there are these issues that, if we have even one thunderstorm, maybe 2 people might need an extra person. The other issue that I haven't really spoke about yet was that we are an upper air site, so we could perform a special sounding, and we do it relatively often, especially for the bigger days or the questionable days with high potential but low confidence in initiation, for example. But we're not going to be able to do that on every marginal day, especially not a day where it's decreasing in threat. And then on top of that, we're not really in the right location here in Bismarck for the prime air mass that we're concerned about, which is in Dickinson. Again, about an hour and a half drive to the west. We're not going to drive that balloon out. So there is the sound. We could have done a special sounding, but just wasn't the right time or location or even threat potential at that moment. So let's start looking at what the evening shift saw satellite-wise, and this is again the day cloud phase, and this is shortly after 20Z, shortly after 3 p.m. local time, and you can see where there's the convergence line there. There's some hints at cumulus beginning to form, maybe some shallow cumulus, but I mean it's in the early stages there. We have, and that's in western North Dakota. We have our obviously our Q field out to the east, but along our front, which is where we're concerned about, it extends north to south there, and you can see that line beginning to develop. And so that, you know, strikes some interest between the two of us that are there at the office at the time, but it's not ringing any alarm bells yet. We thought, you know, with the convergence, there's, you know, the steep low-level lapse rates likely developing at that time. You know, there's going to be some sort of towers, there's going to be some sort of, you know, cloud growth. Now, how much is going to be the question. So it's something to keep an eye on. The other thing we can do is, it is in COVID time, but we do have, you know, we're teleworking everyone else who is not on the operations staff. And so, for example, at this time, we did have all our Sioux teleworking from home. And so discussion, collaboration that goes between teleworkers and the people in the office. And I believe our Sioux was on at the time, and he typically works a little later in the day. So our science and operations officer was there to maybe be a backup if needed. And so we see these clouds developing, and we let him know. And so, hey, there might be something to watch out for here, but we're not exactly sure the extent of this. I'll take a quick look at the 20Z GO16, a couple derived products, which I think interesting picture to what I was talking about before. We have the total precipitable water on the left and the lifted index on the right. And it's interesting to see how the precipitable water is laid out. You can certainly see the north-south oriented gradient in slightly higher precipitable water values to the north, maybe where there's greater mid-level ascent and moistening. And the EML is certainly stronger, that's drier to the south. But then the lifted index is a bit of the opposite. Maybe you have with the warmer or with the cooler, the greater lapse rates to the south, maybe there's a slight, the steeper lapse rates to the south, I'm sorry, there's maybe a little bit of a higher or a lower, a more unstable lifted index further south, closer to the South Dakota border, the North Dakota, South Dakota border there. And so there's a kind of a question of where is this sweet spot? Where on the line can we get convection? Where on this front, what's the coverage look like? And these are the questions where we have to start asking ourselves if we're going to start getting into this mesoanalysis mindset. And I think this is an interesting case because we do have this like one line, you know, it looks relatively simple, but it's such a questionable convective initiation day that it makes it a little more complex. So jumping real quick into the tool that we do have though is our new cap sounding availability, and that arrives early to mid-afternoon here in our AWEBs. And so this is the pass at 19Z, maybe arrives at 1930. I can't remember the exact time, but you can see we have a widespread number of points. And so this is the new caps pass in the early to mid-afternoon. And we do have plenty of spots in western North Dakota to choose from. So if we choose one, like we did that day, as we saw the cumulus developing, it paints a bit of a different picture. We do have this steep mid-level lapse rates, but then the drying, the mid-level drying that we saw from the NAM and the pronounced convective inhibition just isn't quite there. And on top of that, thankfully, in AWEBs, we can change our surface conditions in the observations. From the observations, sorry. We could change those conditions in the plot here itself. So this is adjusted to what that was at the time which was 88, 89 over 62. And suddenly this starts ringing our alarm bells in the office, is that maybe our mid-level SIN, or I'm sorry, our ML SIN is much lower than it was before. Maybe our CAPE is much higher. It's in the 2,000 to 3,000 joules per kilogram range. And maybe the potential for convection is a lot higher than what it was before, or than what we thought, I'm sorry, than what it was before. And so at this point, this is when, this is about 3:30 in the afternoon, and okay, it's time to bring somebody in, and at least have one person here in case stuff goes. You know, we have our balloon later, and we might need the extra hands. Looking at, this did take a while to develop. This is about an hour and a half later, satellite-wise, but we do start to see the increasing agitation of cumulus there. We start to see a couple towers blowing off the convergence line there. Maybe some orphan anviline, but some towers are certainly starting to form. And with the day cloud phase, you can start to see the glaciation as well. So this was like, combined with the new caps sounding that we saw before, maybe our convective inhibition is much less than we thought it would be. This is a great time to start ramping up operations, our tempo, and our messaging as well. So the two things that we did was issue a mesoscale discussion, and then a new but more targeted weather story. As targeted as we could be at that time, with this line being, this convergence line being drawn basically north-south through the state. But I'll be quick here to summarize what we were trying to go for in our messaging. And we did something similar in NWS chat as well, but it was more to highlight that we issued a mesoscale discussion. And essentially, the new cap sounding was the observation that we needed to tip the scales about our convective inhibition, and to tip the scales for what our confidence in convective initiation was. Even though there was the mitigating factors of the, maybe it's the more dry in the mid-levels and the westerlies caused some entrainment, this was certainly enough to ring the bell. And we don't do a mesoscale discussion quite as often. And so this was a good way for our partners to see that we were suddenly seeing a change, and here's where the change was, and that the severe weather threat, or the hail threats especially, was certainly on the rise. And so this is just a quick little recap of what did happen, and you can see warnings put out here, just west of Bismarck, as that line slowly advanced eastward, and especially by that cross section. I don't need to get into that about what that means, but certainly hail producers became numerous. We had at least a few warnings, and all the fast forwarders are end result of one of our bigger hailstones, which was, we ended up with this at least an inch and a half size hail out of a day where we were trying to back off the messaging, and then something tipped the scales the other way, and this was the new cap sounding to really address the forecast point that was a problem earlier, and then we had an additional observation point that really helped out there. So just a quick overview of what we have found in the few times we have been able to use new cap soundings here in operations, and this is just what we've found, and I'm sure subject to change. But the uses that we have found here is, obviously it can take place of a special weather balloon where it's not possible, or in location, timing, or even in an operational tempo like it was that day. The surface conditions on new caps and AWIPs can be adjusted to better match the lower level observations. And that really helps if we bounce over to the limitations real quick, with the limitation of new caps in fully measuring the lower levels of the atmosphere. And so you can kind of get a compromise there between the low level with adjusting the surface observation and then the surface condition, and then utilizing what the data is in the mid levels, or in the upper levels, which it does better at. So it's better at the broad trends, as well as, you know, the mid to upper level lapse rates, the subsidence, drying, capping properties, rather than fully lower level stuff. But for an example like this, it really worked out well. So we've tried to share this usage with our staff, and we had a couple cases like this where it really worked out. And so that's what I have. And if there's any questions, I can take them. And thanks for letting me share this with you.
Thanks, Alex. There is one question that I see. Where can one find the new cap soundings in AWIPS? And I'll answer that one. Under your satellite tab, there should be a SNPP and NOAA 20 selection, and if you choose that, you'll see new caps sounding availability. So I hope that's clear enough. I do have a question. I don't know if back in August you had gridded new caps inside your in your WFO. So I'll ask if you did, and if you no.
Oh, sorry. Go ahead.
No, I'm not quite formulating my question, so I'll just ask: were gridded new caps available to you when this case occurred?
I don't remember them being available to me at the time. I know they came later, or at least I started using them later than I had started using these soundings. But now that I started looking at the gridded new caps more, I wonder if the context of like the property of the cap, for example, there, I don't know if I would pick out the same thing in a gridded sense, but certainly this summer, I'm looking forward to comparing the two.
Okay, let's see. Okay, here's a question from Pete in Jacksonville. Are new cap soundings accessible online for those performing remote mesoanalysis for the local office at home?
Are they?
Yeah.
I'm not 100% sure.
There is a website. There is a NOAA NESDIS website. I will forward it to you, Pete. And if anybody else wants it, I guess I can forward it to everybody who's on the call today. So I don't know the website off the top of my head, so I can't put it in the chat. But yes, you can access these at home. The latency is a little bit slower than you have in the forecast office. In the forecast office, the latency is really great. It's about 60 minutes now, 60 or 75 minutes. And I don't think you'll have the same kind of latency when you go online. And there's also a comment here that when you're doing mesoanalysis, you should be focusing on both observational data and model data, and not one or the other at the sacrifice of the ones you're not looking at. So, look at everything you can to help get a more coherent picture of what's actually going on.
Correct. And I think that was the most exciting part of this. It was another tool, another observational tool, I should say. It does, I guess I could have mentioned, it does only pass, like, for example, over our area, probably every area, just twice in a 24-hour period. So there's for our area, it's, I believe, an 8Z pass, and then we get that 19Z pass as well. So it's just another tool, and seems to work out well when it does.
But it's well timed for convection.
Exactly.
Yeah. Are there any, okay, let's see. So Chris White has, okay, gridded new caps are available online. I forgot about that website. So there's Sport has a website that has gridded new caps fields available. So you can look at gridded fields online. And then you can look at the NOAA NESDIS site that I'll forward around that shows you the individual profiles. So, are there any other questions or comments? If you want to raise your hand, you can be unmuted, but I know we've run a little bit long. This was a great presentation. It was our first satellite presentation on NewCaps. So that was very exciting to hear it. And I appreciate, Alex, all the work you did in putting this together.
Yeah, no problem. Thank you.
And if there are no other questions, I will say thanks again to Alex, and we'll see you next time.